Good afternoon, everyone. I'm Mahmoudul Hassan, CEO of MVision AI. Welcome to this ESTRO Virtual Symposium. Today, we're very excited to tell you more about our AI segmentation service and some other interesting projects that we are working on to improve the lives of cancer patients. In today's agenda, I will give you a brief introduction about MVision, followed by Andres Schulte, our Business Development Director, and followed by Jarkko Niemela, our Chief Product Officer. MVision was founded in late 2017. The core founding team consists of software engineers, medical physicists, and AI researcher. Our cloud-based segmentation service is now clinically operational in 5 European countries, and it's also CE marked. MVision AI is also working on AI-based dose prediction and plan generation techniques. We'll be happy to share some of the results in the coming future. MVision is building a cloud-based physician-driven planning solution. But what is it? Why do we need a cloud-based physician planning solution? Existing planning solutions are driven by physicists and is confined to the treatment planning room. We know the oncologists are mobile and they have very limited time. So it is very natural and evident that they would need some kind of a web-based systems where they can carry a laptop or a tablet and do their clinical work on the go. During this COVID-19 situation, it is more than evident why we need a cloud-based, physician-driven planning solution. There are three major components of this system. A web-based RT engine, which visualizes contours, dose, and DVH. An AI-based automatic segmentation service, which generates the contours automatically. And an AI dose prediction engine and a plan generator, where physicians can easily create clinical grade plans. Let me be very clear. This system is not intended to replace existing treatment planning system. Existing treatment planning systems are driven by physicists and a very important part of planning solution. But we do believe this kind of cloud-based physician-driven planning solution and existing treatment planning systems will increase collaboration between physicists and oncologists to create treatment-grade plans in minutes instead of hours or days. Now I will pass it over to Andres Schulte, our Director of Business Development. Thank you.
Good afternoon, everybody. Thank you, Mahmoudul, for the introduction of MVision, its services, and of course the outlook to the future services we will be offering to the radiation oncology community. My name is Andreas Schulte. I am the Director of Business Development for MVision, being in charge of the global sales and marketing activities. I would like to talk to you today about the remarks and results we got in the last 12 to 18 months from our clinical partners, whom I would like to thank for their ongoing support for our team during the process of development and the implementation of our clinical segmentation services. We're looking forward working with them as well in the future, and we would like to invite you to join the fast-growing network of satisfied clinical users and clinical partners globally. How does it work? MVision is a cloud-based service. You may transfer data directly from your CT scanner, in the future as well MRI scanner, or TPS and PACS to the cloud-based services. How do we make sure that no personal data are transferred to the cloud and leaving the clinical IT system? MVision provides a tool here called MVision Daemon, which is installed on the IT environment of the clinic. MVision has no access to it unless it is granted for service or updates by the clinical user. The tool is therefore always under control of the clinic IT. Personal data always deleted after successful termination of an operation. So these data will not be visible for MVision in case of service or updates. The tool itself de-identifies the image data, and therefore no personal data are leaving the hospital IT systems. Reconstruction of personal data or the identity of a person is not possible from the data leaving the clinical IT systems. In case somebody sends data which has not been de-identified properly, MVision recognizes this while receiving the images and will reject and delete these data. The neural network will then create the contours and sends back only these contours. All images are deleted from the cloud after finishing the segmentation services. The whole data transfer and handling process is documented. The protocols will be provided to the clinical user on a regular basis so that they can prove to their auditors that the user works GDPR compliant. Before the implementation of the services, we provide to the clinical user and the local data protection officer comprehensive documentation of all processes so that all necessary legal documents can be created in collaboration with the data protection officer. This is a very well accepted procedure, for example, in private sites in Germany as well in a public site in Germany. After the more technical part, let's now talk about the clinical challenges MVision addresses. MVision addresses the following three challenges in the radiation oncology process: workflow and workload, quality of contours, and the consistency of contours. You may know the papers showing that already the use of Atlas-based systems might reduce the workload for contouring, and that AI-based systems might further decrease it. Mazur has shown a direct link between the workload and the occurrence of errors in the radiation oncology process. Already, the results from a test in an early phase have shown that the segmentation services MVision can reduce the workload for contouring by 2/3 or more, and that it delivers contours which are in more than 85% of the cases accepted with no changes or minor changes only. This will have a positive effect on the workflow and the workload of the whole team. Since the process of segmentation services runs in the cloud, time is freed up for other tasks, and the user can decide when the images and contours have to be, for example, imported into the TPS. So planners are not waiting anymore for images. Images and contours are waiting for the planner. MVision's segmentation services are guideline-based. When creating the ground truths for the training sets of our deep learning algorithms, our experienced annotators have been following guidelines from ESTRO, EORTC, and other international accepted groups. You may see a selection of the guidelines followed here. Guideline-based means as well that there's no need for any data from a new clinical user. The moment we have implemented our services in the clinic, which can be done, by the way, completely remotely, the services are ready to use directly. No data collecting, contouring, reviewing, etc. is required by the user. In case the clinical user would like to get a specific model, we can either train with the data for a clinic-specific model or include the training sets provided by the clinic to the global models. Well, guidelines are one thing, but what about test data? You may see here the results for our just released prostate model. Almost all results of the volumetric DICE similarity coefficient are above 0.8. Only small organs or structures show a DSC below 0.8, which is mainly caused by the size of the structure and not caused by the missing accuracy of the method itself. The models will be updated regularly, and new organs will be added to the models as well on customer request. All models are customizable, list of organs, names of organs, and colors. Jarkko Niemele will give you more information about that. Last but not least, a neural network and deep learning algorithms reduce the intra and inter-observer variability. We all know that the variability of the segmentation of a structure shows large differences when multiple persons do the segmentation, or even if one person does a contouring of one structure on different days. The neural network gives you always, for the same image set, the same contours, Monday through Friday and on weekends, 24/7. Let's come to our last part of the presentation. I would like to hand over to Jarkko Niemele, our Chief Product Officer, who will show to you the results of the just released organ models and will give you as well an outlook to the models coming soon. Thank you very much for your time and joining our webinar. I will hand over to Jarkko Niemele. Thank you very much.
Thank you, Andreas, and thank you, Mahmudul, for your presentations. My name is Jarkko Niemele, and I am the Chief Product Officer at MVision AI, and I have a wide expertise in medical physics. Okay, I'm really excited to show you the capabilities of our segmentation service for radiotherapy that has been CE marked. It includes deep learning algorithms that produce robust organs at risk and target auto-segmentations for CT imaging in 6 different anatomical sites. These are the head and neck, abdomen and lung, brain, male pelvis, female pelvis, and breast. I will go through some example scans and segmentation results our collaborating partners have provided us while using the cloud service. Before I go to the example segmentations, I'd like to point out that the service may be easily configured to your liking. You might want to have your own names and colors for the structures that you receive from the service to follow the special clinic convention or maybe a national consensus guideline your clinic complies to. Also, for the head and neck case, you might want to configure different kinds of ROI selections for targets, say nasal cavity, as opposed to targets in the larynx area, just for an example. We have followed carefully selected consensus guidelines that our models comply to. However, we are easily able to train the algorithms to produce a different style for an ROI should there be a need. An example of this would be the optic chiasm and optic nerves in head and neck and brain models. They indeed produce 2 different styles of segmentations, one according to the consensus guideline Tahanka 2015 by Brewer et al., and the other according to 2015 Scoccianti et al., where in the latter case the optic chiasm would have the conventional X-shaped structure. First, we have an example of the head and neck segmentation. The algorithm is able to produce 45 different organs at risk. As we go down to the caudal direction, we can see there are the body and brain. Next we have the brainstem together with the 2 different styles of optic chiasm and optic nerves, from which you may choose the one that complies with your protocol. Then we have 2 different style eye structures, the lacrimal glands and pituitary gland. Here you may also see the carotid arteries running on the way down to the larynx. Small cochleas may be seen here, and further caudally we have the mandible bone and the parotid glands. The algorithm finds the lateral parts of the parotises nicely. The brainstem would be attached to the spinal canal and spinal cord. Next we have the constrictor muscle, the buccal mucosa, lips, and the oral cavity. Here we can see strong artifacts from dental fillings. The algorithm does not have difficulties to correctly segment the ROIs in these areas either, as it has been trained with plenty of scans with different types of artifacts included. Further down we have the submandibular glands. Next we can see the supraglottic larynx with constrictor muscle running further down, and then we have the cranial part of the brachial plexus. They locate between the anterior and middle scalene muscles. The supraglottic larynx is attached to the glottis, and just below that are the small arytenoids. Then we have the cricopharyngeal inlet together with the thyroid gland. The carotid arteries are still running lateral to the thyroid, and brachial plexuses are broadening laterally. Finally, we have the cervical esophagus and the lungs. The breast model can produce the humeral heads, esophagus and trachea, the spinal cord, lungs, left and right side of the breasts, the heart. Then we have the liver, spleen, stomach, the kidneys, and the pancreas. We will make an update for the breast model in near future to include the lymph levels. In the abdomen and lung model, we have the same ROIs as in the lower part of the breast, so the kidneys, the liver, the spleen and pancreas, as well as the stomach. And when we go further, cranially we can see the heart and esophagus is going there, as well as the trachea. In the female pelvis model, we have the rectum, uterocervix, femoral bones, the bladder, together with the bowel bag and the kidneys. In the male pelvis model, we have the femoral and pelvic bones, the rectum, the penile bulb, and then we have the pelvic lymph nodes, the prostate, and fiducial markers inside the prostate. The model won't segment the calcifications in the prostate. Seminal vesicles are there, together with sacrum bone and the bladder. Then the rectum is attached to rectosigmoid, and that in turn to large bowel. Then there is the small bowel, and when we have a look at the right side of the patient, we can see that there is also the descending part of the large bowel. And then we have the L4 and L5 vertebra, and of course the bowel bag. Next, I'd like to show you two prone position patient scan examples. Our deep learning algorithm has a sort of intelligence where it is capable of producing correct results even when in the training set it hasn't seen a patient scan with this type of prone position. We have included here two prone position examples where the algorithm does a very good job on both. And this flexibility in MVision auto segmentation is further increasing among the updates we are releasing in near future. Quite in the near future, we will have models for MR images as well. We are testing the male pelvic models at the moment, and we are developing both MR and CT models for an updated brain and head and neck segmentation. The brain model that we are testing at the moment will include at least the structures seen here, namely the cerebrum, corpus callosum, thalamus, hypothalamus, hippocampi, and cerebellum. The head and neck model will include all the neck lymph node levels for both CT and MRI. And finally, I'd like to show you we've done some advancement with the CBCT and synthetic CT auto segmentation. Now I'd like to thank you for your interest, and we are more than happy to answer all your questions you have sent through this web event. We have also a web browser-based demo available for your clinic to test our auto-segmentation service results with your own scans. Only then you are really able to see the robustness and accuracy our algorithms are capable of. Please contact us via email to request a free trial. I hope everyone stays healthy, and we'll see you soon face to face. I wish everybody a great week.